Hello class! Today what we're going to talk about is proofs again. Only this time, instead of talking about a two-column proof, what we're going to do is talk about a flowchart proof, which is pretty much the same thing, it's just a different way of presenting the information. And we use a flowchart instead of putting it into two separate columns, hence the name. So we have this one here. Here we have the same proof that we did last time as a two-column proof, only this time we're going to do it as a flowchart proof. So we have the given information, we have the information that we're trying to prove is true, and here we see this lovely flowchart that they have already filled out for us with all of the statements. We've just got to match up the reasons with these statements. We've got the reasons down here. So what I'd like you to do, pause the video and match up the reasons with the statements. Okay, so now you're back. We have statement number 1 here. Measure of angle 1 equals the measure of angle 3. How do we know that? We know that because it's given to us. They gave it to us right here, and they marked it on the diagram. Those are equal to each other, and so that is given to us. Statement number 2, which you see is on a different line here, so it has absolutely nothing to do with statement number 1, other than it is talking about a picture, of course. So here we have measure of angle EBA equals the measure of angle 2 plus the measure of angle 3. How do we know that? Well, we have EBA, so that's this angle here, and that is, you see, angle 2 plus angle 3. They're adjacent angles, so we can add up those measures to get the measure of the whole thing. And so that would be angle addition postulate. It says we can do that. Okay, so now we have this next statement. And we see that this is coming from statement number 1 and statement number 2. So we see how we created this statement. This is the measure of EVA equals the measure of angle 2 plus the measure of angle 1. Well, what did they do there? Well, it was 2 plus 3, and now it's 2 plus 1. How did they get the 3 out and put the 1 in? Well, since it's a flowchart, we see, well, that part must have come from over here. Angle 1 equals the measure of angle 3, and if one thing equals another, we can take them out and use them interchangeably. That is the substitution property of equality. Okay, so coming from this statement to the next statement, what happened? What changed? Well, the only thing that changed here is that this was 2 plus 1, and now it's 1 plus 2. Can we do that? Can we switch the order of addition problems? Yeah, we can. 2 plus 3, 3 plus 2 is 5 either way. Who cares? Right? So that is the commutative property of addition right there. Okay, so now we have another statement down here on this next line. And we see that this is totally new. It has no errors coming to it from anything else, so it's all on its own. What do we know that will help us out here? Well, we know the measure of angle 1 plus the measure of angle 2 equals the measure of angle CBD. Right here, CBD, that's this large angle. It's made up of angle 1 plus angle 2. Hey, I'm adding them, right? Adding angle addition postulate. Same thing we used right here. Now on this last one, well, where did this come from? This is what I wanted to prove, but how do I know it? Well, we took the measure of angle 1 plus measure of angle 2 equals the measure of angle CBD, and we put that together with this one here. We know that's where it's coming from because we've got the arrows here. And so, how do we put this with this to create our final statement? Well, if we notice, we have this equals 1 plus 2, and 1 plus 2 equals CBD, so EBA and CBD both equal 1 plus 2. I have two things equal to a third thing, a third statement, so they must be equal to each other. That is the transitive property of equality. Right? So there it is. We have this lovely flowchart that shows how we get from this to this, backs up everything. Right? And last time we did the same thing as a two-column proof, so if you want, you can flip back to the last video and see it as a two-column proof instead of a flowchart proof. All right. Real quickly, we're going to talk about a new theorem. We have the right angles congruence theorem, which says that all right angles are congruent. And I want to know what you're thinking. That's pretty obvious. Of course they are. They're all right angles. But we do need to prove it, and we already use it sometimes, and we don't want to prove it every single time we use it. So we have a theorem to kind of shortcut that. All right. So Let's take a look at this. We are going to prove it. There we go. So here I have angle 1 and I have angle 2. They are both right angles. We want to prove that they are congruent, because remember, theorems can be proven, postulates can't. So what we're going to do is we're going to start this off in a flowchart proof, and then we're going to put it as a 2-column proof, just so we can see them side by side to look at those. So here it is as a flow proof. Start off with our given. Angle 1 and angle 2 are right angles. So what does that mean? Well, that means that the measure of angle 1 is 90 and the measure of angle 2 is 90 degrees. Definition of right angles, right? Well, what does that mean? Well, if 1 equals 90 and 2 equals 90, again, we have two angles equal to the same thing, therefore they must equal each other. Transitive property of equality. And so we have this measure of angle 1 equals the measure of angle 2. Well, if two angles have the same measure, by definition, they are congruent. So we have now proven that this theorem is true, and we've done it in a flowchart. Now, it did want us to put in a 2-column proof, so let's go ahead and do that. Right over here, 2-column proof. We start off with our 2 columns, statements over here on the left, reasons on the right, and you'll see that we have these same statements and the same reasons. All right? Exactly the same as statement 2. Exactly the same as statement and reason number 3. Exactly the same as statement and reason number 4. It's just here it goes step by step by step like this, and over here we've got arrows saying it goes from this one to that one to that one to that one to that one. So the flowchart proof is very visual. The 2-column proof is a little bit more organized, is a nice little list. So if you like lists, you might like the 2-column proof. If you like to see how stuff moves from one thing to the other, then maybe the flow proof is for you. Right? You see, they have the exact same information, so it's really largely a question of style. Which one do you like? Right? Couple more theorems here. We have the congruent supplements theorem and the congruent complements theorem. What this says is that if two angles are supplementary to a third angle, or to some congruent angle, then they are congruent to each other. So, for example, let's just put this with some numbers to make a little bit more sense here. If, for example, angle 2 is 100 degrees, and angle 1 is supplementary to angle 2, then that means that angle 1 must be 80 degrees, right? Because that adds up to 180, definition of supplementary. Well, if angle 3 is also supplementary to angle 2, then angle 3 must also be 80 degrees. And as we see from this, angle 1 and angle 3 are congruent. Okay? And so that's what this is saying here. All right? Congruent complements theorem is the same basic thing, only it's with complementary angles instead of supplementary angles. So angle 4 and angle 6 are both complementary to angle 5, so angle 4 must be congruent to angle 6. All right. Two angles that are complementary to the same angle or to congruent angles, then they are congruent to each other. All right. So let's see what we have here. All right. So what we have here, we are going to use this 2-column proof, and we are going to prove that the complementary angles, the congruent supplements theorem, is true. Prove that it works. So we know that angle 1 and angle 2 are supplementary. We know that angle 2 and angle 3 are supplementary. So here it is as a 2-column proof. That's given to us. By definition, that means that angle 1 and angle 2 equal 180. Angle 3 and angle 2 equal 180. Alright. Nope, so I'm cutting stuff off. And then we have here that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2, 3 equals plus the measure of angle 2. How do we know that? Transitive. These both equal 180, so they must both equal each other. There we go. Alright, so now we wanted to prove that angle 1 is congruent to angle 3, so we need to get rid of these 2's, so we can just subtract the measure of angle 2 from both sides. So with the subtraction property of equality, and there we go. This angle equals that angle, which means the angles are congruent. Definition there. And here it is as a flow proof. All right, and as you see, a lot more visual. Okay, and just had seeing lists here. Okay, where did this one come from? Well, it came from way up here. Where did this come from? Well, it came from up there. Here we can see that. And so we can see these two go together, these two go together, and then this comes together into this one statement where it becomes the transitive property of equality, which then flows down to give us our congruence. So you can see how this is a lot more visual, and it's a lot easier to follow, especially if you have some really complicated proofs. We have to take 3 or 4 things and put them all together. This way you can see where they're from. All right. Okay, last thing we got here, we have the linear pair postulate, which says that 2 angles form a linear pair, then they are supplementary. Linear pair postulate, that angle 1 and angle 2 are linear pairs, they must be supplementary. Vertical angle congruence theorem, this says that all vertical angles are congruent to each other. Angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. And that stuff y'all already knew. You probably knew that from 8th grade or something like that. But here it is, as a theorem, they have proven it. So let's take a look at this. We're going to prove this. And what we have here, this is the vertical angles congruence theorem. We want to prove that angle 5 is congruent to angle 6, but you'll notice this proof, it's not a flow proof, it's not a 2-column proof, this is a paragraph proof. So if you want to pause this for a moment and read that. Alright. This is, without a doubt, my least favorite format of proofs. Alright. As much as I read, I still don't like to read this. Alright, I want to read something like, I don't know, Mockingjay or things like that. I don't want to read this. This is hard for me to follow. I need to see it step by step by step. I like the flow proof. I like the 2-column proof. This, everything tends to run together on me. But here it is. Angle 5 and angle 7 are vertical angles formed by intersecting lines, as we see in the diagram. Angle 5 and 6 are linear pairs. Angle 6 and 7 are linear pairs, which means these are supplementary. Angle 5 is supplementary to 6. Angle 7 is supplementary to 6, which by the linear pair postulate. Alright. And by the congruent supplements theorem, since these are both congruent, supplementary to 6, they must be congruent to each other. Alright. And that's how that works. And this is a paragraph proof, which I really don't like. So here we have the exact same thing as a 2-column proof, which we see vertical angles, that's given. That these are linear pairs, how you know, definition, as shown in the diagram. And so by the linear pair postulate, those are supplementary, and then they are congruent because they're supplementary both to angle 6. Right? I like this. This jumbles up in my head. I'm not real fond of it. But you do need to know how to do it, because your teacher's probably going to put it on a test sometime. So there's that. Right, so here we have just a summary of the 3 different kinds of proofs. All of these are proving the symmetric property of angle congruence. Prove that if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. First as a 2-column proof, then as a flow proof, and finally as a paragraph proof right down here. All right. So you see they all have the same information. The difference is how is it presented. Personal favorite, I like the flow proof. I think it's kind of cool. 2-column proof, that's nice. I understand them. They make sense to me because I've been doing them since high school. That's what I was taught. That's the only way I was taught in high school. And then we have the paragraph proof, which I really don't like, but it works. And so some people might like that if they're like into literature and writing and don't like symbols. Anyways, there it is. That is flow proofs and a little bit of paragraph proofs. I hope it was useful to you. I will see you next time.